Welcome to day 2 of Advent of Code of 2023. So, in this puzzle, Cube Conundrum, we have a number of games that get played. So, we have a small bag of cubes, which are either red, green, or blue. Each time you play a game, will hide a secret number of cubes of each colour in the bag. Your goal is to figure out the information about the number of cubes. To get the information, once a bag has been loaded with the cubes, the elf will reach into the bag, grab a handful of random cubes, show them to you, and then put them back in the bag. He'll do this a few times per game. You play several games and record the information from each of the games, which is your puzzle input. Each game is listed with its ID number, like the number 11 in game 11, followed by a semicolon, separated by a list of subsets of cubes that were revealed by the bag from the bag. 3 red, 5 green, 4 blue, for example. So, for example, the record of a few games might look like this, and so I've just taken this as the example input, and I've popped that up here as my little test. So in game 1, 3 sets of cubes are revealed from the bag, and then put back again. The first set is 3 blue, 4 red, and the second set is 1 red, 2 green, and 6 blue, and the third set is just 2 green. The elf would first like to know which games would have been possible if the bag only contained these cubes. So 12 red, 13 green, 14 blue. In the above example, games 1, 2, and 5 would have been possible if the bag had been loaded with that configuration. However, game 3 would have been impossible because at one point the elf showed 20 red cubes, and if we're only limited to 12, we can't have 20. And game 4 would have been impossible because the elf showed 15 blue, and we're only going to have 14 blue. If you add up the IDs of the games that would have been possible, you get 8. Determine which of these games would have been possible if the bag had been loaded with the 12 red cubes, 13 green, and 14 blue. And what's the sum of the IDs of those games? So as you can see, I've already done this part, and we can see the top of part 2 here. So we get the test input, and we get an example of 8. So what we're going to look for when we run our solution on this test input is that we're getting 8, and we're also going to run it against our actual input data at the same time, aiming for 2406. So the approach that I took with this one was a completely iterative approach. So that's what I'm going to show you. It's not probably the most efficient in any way, shape or form, but it gets the job done. And I have been finding that these puzzles for Advent of Code have helped in my day job, trying to figure out small little problems as they come up, and kind of being a lot more comfortable with just throwing a quick couple of lines of something together to solve a problem, and then coming back to it later on and doing a bit of refactoring. But I've been liking these Advent of Codes games, puzzles for that so far. So anyway, here's the way that I went through day 2, part 1. So firstly, we have these constraints listed here: 12 red, 13 green, and 14 blue. So because of that, I set a little variable at the top here, just a little dictionary of the limits themselves. So this one was 12, then we have green as 13, and then we have blue as was it 14. Cool. So we've got some constraints there that we can use. We could also just put those within. We could also just put those within the code itself, but I decided to just put them at the top here, just so we can kind of refer to them throughout and not have to keep checking For 3 different things, we just check for the key. We'll check for the value of the key. So we've already got a variable called total. That's still going to be a number. Sometimes they change it up in the puzzles to you have to input a string of characters, but all of the puzzles so far that I've actually completed this year have been numbers, which is really great. Anyway, so we've got the total at the top here. We're still returning an integer. So we need to go over each of the lines. So let's do for line in input. It's just string, isn't it, up here? Dot split lines. So what we want to do here, as it says, we can get the game, which is pre colon, and then all of the actual hands that are dealt are post colon. So if we then do the game and the hands is equal to line dot split, and this one we're going to split just so we can strip out the extra space as well. We're going to split it on the colon space. So then the game ID is going to be the game, and we are going to remove the prefix of game. So that will just convert that to a number. So we've already taken out the colon onwards because of the splitting it on the colon space. So now we've just got to deal with the game and the number. So if we just remove the prefix game, then we're all good. We could, because we know that this is a fixed length, it's always game space number. What we could have done is said go from the 5th character onwards. That would have also done the same thing, but do remove prefix. So for each one, we want to check if the game is possible. So let's just start off assuming that it is by setting a little variable to true. So now we're going to go for hand in hands dot split. We're going to split that on a semicolon this time. Semicolon space, because we've got the we can see that's how it always splits here, so it always starts one space over. So if we then just do on semicolon and a space. So what we're going to do here, we're going to firstly, as we're going through stuff, we want to have a break. If the game isn't possible, want to exit out of it. Don't necessarily need to, but I think it's kind of a good practice to just kind of go, okay, in an iteration, is there anything that causes me to not need to carry on any further? In this case, it would be if not game possible, and then we're going to break. Cool. So then for each of the for each of the hands, we have cubes. So what we're going to do is say the cubes is equal to hand dot, and we're going to split that across the comma and space. So that's between these characters here. So we're getting all of the individual parts, red, green, blue. So that will give us the individual cubes. So then what we want to do is for cube in cubes, obviously we could have just not necessarily made a cubes variable here, and we could have just said for cube in hand dot split, but I like to make some additional variables here and there, why not? So we have the count and the color. All you Americans watching are gonna look in disgust as I use a U for color. Just deal with it. Cube dot split. I'm splitting it the correct way. We're going to split it on a space. And what we want to do now is check if the count is greater than the game limits color. And if it is, then we're going to say game possible equals false, and we are going to break. So this will break us out of this loop, but then game possible false will also then break us out of this loop here for the for each of the hands. So if this first one is not possible, we don't really want to carry on with the rest of these because the game itself is not possible. Cool. So then we're going to break, and what we then want to do after we get to the end of the loops for the hand, we want to say if game possible total plus equals the game ID, which we have already done as an integer up here. Cool, okay, so let's give that a little go. So we get 8 and 2406, and we have 8 and we have 2406 here. Nice one. Okay, so all I've done is very quickly copy over the code from part 1 to part 2 as a starting point. So for part 2, we have an elf says that they have stopped producing snow because they aren't getting any water. He isn't sure why the water has stopped. However, he can show you how to get the water source to check it out for yourself. It's just up ahead. As you continue your walk, the elf poses a second question. Of course, there's always a second question. In each game you've played, what is the fewest number of cubes for each colour that could have been in the bag to make the game possible? So this is a slightly different variation on the puzzle. Again, consider the example from earlier. So we have the same example input. So in game 1, the game could have only been played with as few as 4 red, 2 green, and 6 blue cubes. If any colour had had 1 fewer, the game would not have been possible. Yeah, so that's because if we have a look with this one, so 4 red for game 1. So here we have 4 red, and here we don't have. We just have 1 red, and here we have no red. So the maximum that we were looking for, the minimum we're looking for is 4, because if we had less than 4 of the red, this game wouldn't be possible. Now, then we have 2 green, and we get that from these 2 here and these 2 here, so we have the same amount of greens in both. And then we have 6 blue, so we have 3 blue here. But if we had had 5 blue, this game wouldn't be possible. This hand wouldn't have won, wouldn't be possible, and therefore the game wouldn't be possible. So we need to get the maximum number of each of the colours from here, of each of the hands, and that becomes the minimum amount for the game, if that makes sense. So instead of having game limits, we no longer have game limits. So instead with this, what we want to do, so we still have the game and the hands. We don't necessarily need the game this time, so we could probably actually just set that to an underscore, and then we'll just get rid of this. So then what we do for each row. Instead, if we make a game mins, so this will be how many of there are for red, how many of there are for blue and for green within the game itself. So for hand in this again, so this time we're not checking for a impossible game at all. So we get the cubes in hand split. So in this one, let's change this up and let's just do hand dot split, and we're gonna do by that there, and then we'll get rid of this. So for each cube, we then want the count and the color. So then we will just simply do if color in game mins, then we're going to set it to what do we want to do? So let's get rid of all that. So then if we just do, so if it is in there, then we want to set the game mins color to the max of game minimums of the color and int of count. If it's not already in there, then we want to say the game mins for color is equal to int of count. So what we could also do with this is use a default dictionary, but just for the sake of simplicity, I decided to just use a normal dictionary, so it doesn't default to 0 for us. Cool, okay. So then if we get rid of all of this, then at the end of the loop for the line, we then want to do the total plus equals game mins of green multiplied by the game mins of red multiplied by the game mins of blue, like so. And because we're not using the we're not checking to see if the game is possible anymore, we can get rid of this as well. Now if we pop back over to here and we just run Python part 2, so now with this we can see 2286 as the example that they gave. So this was because we took the power of the set of cubes, the power of the set of cubes is equal to the numbers of red, green and blue multiplied together. I didn't mention that at the very start. And the power of the minimum set of cubes in game 1 is 48, blah, 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 blah. So that adds up to 2286, which we have up here. And then we have what is the number of the power of the sets in the actual input. And in my actual input, it was 78375, which we can see is exactly the same as what we've got here. So that is the solution to part 1 and part 2 of day 2 of Advent of Code 2023 in Python. I'll probably also do this in TypeScript and Go. The Go one is relatively similar to this, is how I solved it, quite iterative approach. An approach with looping with a for loop. With TypeScript, I believe I solved it a little bit differently, but yeah, this is how I did that. So thanks for watching, and stay tuned for day 3 of 2023. Peace.